Hello students, how are you all? Welcome to the class. Students, today we are here to start a new chapter. The name of that chapter is Energy. You know that work has different meaning for different people. Like when we study, we do mental work, and when a worker carries bricks and cement to higher floors on buildings, he does a physical work, and this work is against the force of gravity. But in science, work has a definite meaning. The technical meaning of work is not always the same as the common meaning. So what is work here? Actually, if you lift an object above the ground, you do work. If you pull something, you have to, you have done some work here. In these cases, you applied some force which moves the object. In science, work is said to be done only if a work moves here, if a force moves on object. Now, the work done by force on a body depends on two factors. First one is magnitude of the force, and second one is distance through which the body moves. Here you are seeing that a force is applied here on this object and finally it moves here. Now we can define work as follows. The work done is moving by the body. It is equivalent to the product of force applied on it and the substitution. Okay. Now next thing is here, the unit of work. So here work is the product of force and distance. Now how will you calculate the unit? So here unit of force is Newton, and the distance which is covered, that means displacement, that is in meter. So when here, so the unit is Newton meter. Here when a force of 1 Newton moves on a body through a distance of 1 meter, it is on its own direction, then the work done is known as 1 joule. So the work's unit is joule, thus the SI unit is joule, and this work is a scalar quantities. Here a numerical problem is given that force is 5 Newton applied and displacement is 2.5 meter. Now we know that work done is force into displacement, so you will find the 5 into 2.5 and 12.5 joule total work done is. And in second numerical, you will find 125 Newton force is applied and displacement is 12.5 meters, so displacement is multiple of both. Next conditions, in few conditions, there is force applied but no work done. Now that means zero work is done in that conditions. So here it is said to be done by the force applied by you when, but work is not done in few cases. Thus in physical, no work is done if an object or any body does not move on applying a force. That means here you can see that this boy is pushing a wall, but he is unable to do any work though he is applying the force. And here a passenger, he carries the bag and that bag is heavier, but no work is doing here if he is standing at its own place. Now energy, if a person can do a lot of work, we say that he has a lot of energy or he is very energetic. In physics also, anything which is able to do work is said to possess energy. Thus the energy is ability to do the work. Students, energy is that ability to do the work. So the energy of the body is transferred on the object, and finally by gaining energy that object moves. So unit of energy, that is very same to the work. Students, the unit of energy here, unit of work and energy both are same. So the SI unit of energy is also joule. Somewhere work is done and equal amount of energy is consumed. Keeping this in mind, we can define 1 joule energy as follows. Here the energy required to do 1 joule of work is called 1 joule energy. So joule is a small unit of energy, so sometimes a bigger unit of energy called kilojoule. You know that 1 kilojoule, it contains 1000 joule, like 1 kilogram is equal to 1000 grams, same. Now mechanical energy, here that the sum of kinetic energy and potential energy is known as mechanical energy. Here a body is said to have known as mechanical energy A body is said to have mechanical energy if it is possess either potential work here, that means either potential energy or kinetic energy, both. Okay. Now, energy exists in many forms. The main form of energy are kinetic energy. Here, see here, first one is kinetic energy. So here, a moving cricket ball you are seeing, and it pushes that stumps. So here is kinetic energy, and now thus a moving body is capable to doing work and hence possess energy. So the energy of a body is due to its motion, that is called the kinetic energy. In other words, every object around us which has speed possesses kinetic energy. So every object which have speed that possesses kinetic energy. For example, a runner has kinetic energy, a running motorcycle has kinetic energy. So what is the formula to calculate the kinetic energy? That is half mv square. Here m is equal to mass of the body and v is equal to velocity of that body which is moving. So by the help of this formula you can calculate the kinetic energy, that is half mv square. Now from this formula it is clear that the kinetic energy of body is directly proportional to the mass of the body. That means when mass is increases, the kinetic energy will increase. Okay. Now second thing is potential energy. Students, we will discuss about potential energy in our next video. Till then, thank you everyone.